Hello and welcome to the hands-on workshop about the WinCC OA Manager for JavaScript. My name is Jürgen Steiner. I'm the lead developer for this feature, and I want to show you how to use this feature as a developer when you want to use JavaScript or TypeScript in the WinCC OA environment. You've probably seen Markus Weber's overview video about this topic. If not, there's a link in the description. And before we start, I would just want to give a quick overview about the 4 technologies we are using and now are integrated into WinCC OA. So, the 4 technologies are, the first one is JavaScript. It's a high-level programming language that was originally developed for browsers to implement the interactive part of websites. So basically every website you encounter on the World Wide Web will use JavaScript to implement its interactive features. It's supported by all major web browsers for a long time. They have built-in engines that handle the JavaScript code. And one important feature, it includes a just-in-time compiler, which allows you to run the code much more performant than if it's just interpreted. The next technology is Node.js. Its slogan is "Run JavaScript everywhere." As I mentioned before, JavaScript was developed for browsers, and now Node.js is here to allow you to run JavaScript outside of browsers for server processes, for other applications. It is based on Google's V8 JavaScript engine and is an open source software that you can use for free. An important part of Node.js is the Node Package Manager, NPM. It is the world's largest software repository containing about 3 million packages. It's open source, and it is not only used to provide with algorithms, interfaces, and all the stuff you need to develop your Node.js applications, but also used by Node.js itself to structure your software that you develop, as we will see in the example later on. And the last technology is TypeScript. It's JavaScript with syntax for types. It's built on top of JavaScript. It actually transpiles from the TypeScript code you write to JavaScript code that is then executed in Node.js or in the browser. And it supports strong type checking and other features that help you in develop more stable, more secure code and find problems already in the development phase and not later on when you're actually running your software. For our hands-on example, we will implement a simple geocoder. Geocoding is the process of converting street addresses to geographical coordinates in latitude and longitude. There are, of course, services on the web that provide this feature, and there are NPM packages that provide a simple interface to use these services. And this is what we will employ to implement this feature in a simple WinCC OA Manager for JavaScript. The typical steps to do such a thing are: first, you will create an NPM, a Node.js module, based on a template provided by us. Then you will search, find, and then install an NPM package that provides the feature you need. Then you probably will want to test this NPM package before you use it to get acquainted with it and understand how it works. Then you normally will connect to WinCC OA data. In our case, this will be the street address that we want to convert. We'll get it from a database field. And finally, once the conversion is finished, you will want to write the results, in this case the geographical coordinates, back to WinCC OA in a different data point element. So let's go. Okay, for the first step, we take the template provided by WinCC OA and based on that create a module which we will use to implement our geocoder. So the template you'll find in the installation directory. There's a new JavaScript directory. This is new for 3.20. And in there you find examples, templates, and some other stuff. We look at the templates. And one thing you see here, we have templates for JavaScript and TypeScript. As I already mentioned, we support both languages. I would strongly recommend to use TypeScript. It has a lot of advantages like type checking, making your code more secure. It has a little bit a steeper learning curve at the beginning, so you need to invest a little bit more. We will see this in the example as well, but the benefits outweigh this additional effort you have at the beginning, and you will find that a lot of problems are already flagged by the compiler before you even know that you have a problem. If you do the same thing in JavaScript, you will find out that you have a problem when the thing crashes or doesn't do what you expect it to do. So the templates come with a README file, and I can tell you that the first thing in this README file is to copy your template into your project. So I've prepared, of course, a project called Geocoder. Also, every project has a JavaScript directory, and we copy this in here. And then we rename it to something more useful, like Geocoder. And for everything else, we open this directory now in Visual Studio Code. You can use other IDEs as well. I'm used to this one, so I'm using it. And what we see here is now the files that are in this template. The most important stuff is we have some TypeScript code that we then will have a look at it, and it will show us how this manager works and how the interface to OA works. We have a package JSON which defines the tools we are using for development. And we have this README which describes how to complete setting up the module from this template. So we've did the first step, we did the second step. It's also a recommendation, it's not always necessary, but sometimes it is, to make sure that you have complete write access to all files, because we copied this from a read-only directory, so you might have problems writing to all these files. So change this now. Yeah, next step is to rename the module here in package JSON. It is a convention to use the same name as the directory name, and we save this. The next step in the README is to open a command prompt. This is already built into Visual Studio Code. We have a new terminal, and it opens in the correct directory. And then an important step is this npm install, which we can as well copy from here. And we need, only for development, not for the production system, but for development, we need to specify the path where the type description for our API can be found, so the TypeScript compiler can check your code against these definitions. And these are also in the product. Next to the templates, there's a directory called types, and in there there's a directory called WinCC OA Manager, and this directory we copy here as well. So this npm install does two things. The first is establish a link to this directory we just given in this command line. So the TypeScript compiler will find the definitions it needs. And the second one, it will look into this package JSON and everything we have here, the dev dependencies, like most important, the TypeScript compiler itself. And it will also install all these development tools. And this now downloads all the stuff from npm. Can take a while. Yeah. And you'll see we have now a directory node modules, which contains all the stuff it downloaded. It's not only these modules we have here, but everything that is required by these modules is also here. And now we are already independent from the web again. Everything that is needed has been copied to this directory and can now be used locally. So the next step in the README is now to compile our TypeScript file. We have this index.ts, and we just execute this command. and it will create a JavaScript file out of this TypeScript file. Here's the JavaScript, here's the TypeScript file. Okay, so we have now the module ready for using it. For using it, we need to add a manager. I've already done this, but I'll show you again how to do it. So you open a new manager, you select the node, JavaScript Manager here. You might wonder why it's only called Node and not a name started with WinCC OA. This is because we are using the original Node installation without any modifications. So the executable that is running when the manager started is the Node executable, and we're just adding our interface to OA as an add-on to the running system. So this is the reason why you have Node here. And the only parameter we have to give is the name of this index.js file relative to this JavaScript directory in the project. So this is geocoder index.js. And we only want to start it manually. And now we can test it. For this, we open our log window and start this manager, and let's see what happens. So this was quick, but as mentioned in the README, it worked because we have now two messages here. This one, JavaScript Manager working, and this value, which have been written into the log by our manager for JavaScript. So to give you a little bit more detail, we now will look at this example code that is part of the template. How is this implemented, and we will use this also to explain some concepts that might be new for you as a WinCC OA control developer, or also some things that might be interesting for you if you're experienced JavaScript or TypeScript developer. So the first thing is we need to import, as it's usual in TypeScript, our manager class. This is the class that implements the API. The module is called WinCC OA Manager, and we will create an instance of this one class, which will then be used as the API to WinCC OA. One important thing, WinCC OA Manager is not part of package.json, which will surprise a seasoned JavaScript developer. The reason for that is we provide the correctly compiled version of this manager and add-on with our installation, and it's compiled against the exact version of the installation. So it is important to take it from there and not from npm or any other package source. Okay, the next thing we look at is we have a main function here. We'll come to this async soon. The main function does the stuff we want to do with this manager. One important thing that is different to control, you have to explicitly call the main function down here. So it's not called automatically also if it's called main, but we have to call it explicitly. If we now look at this main function, we do something simple. We do a dpget here. Dpget is not a function as in control, but it is a method on the WinCC OA object. So that's the way we call it. We pass a DPA name to it. You probably recognize this one. And one important thing, we have to await for this. So what does this mean? dpget, as a lot of other methods and functions, is asynchronous. This means when you start dpget, it is not finished immediately. It has to talk to another manager to get the value. The manager answers then with a message that contains this value, and then dpget can continue. This in control is handled automatically by the control interpreter. You're not aware of this, but this is what is already happening in control. But in JavaScript and TypeScript, to achieve the same behavior, you have to await all asynchronous functions. So how do you know when you have to await the function, when not? This is, you see it in the method signature. Everything that returns a promise, like this one, needs an await in front of it. If you know more about JavaScript and TypeScript, you know there are other things you can do with promises, but for the normal use cases, you will await it. That's the reason why we have it here. And if you have a await in some function, you need the async keyword at the beginning of the function. That's what JavaScript dictates. Yeah, the next thing you might see here is this try catch block. So the error handling in JavaScript, TypeScript is normally done with exceptions, with throwing errors, and we've adapted this also for our API. So when our API reports an error, it will not report a special value or something else. It will throw an exception. And if you don't handle this exception, your manager will terminate with a fatal error, and you will see where it terminated with a call stack in your log file. If you don't want to have it terminating, you need to catch it. The try and catch is the same as in control. You get an exception here, and you can report this exception to the console, and then program execution will continue as before. Which leads me to the next point. Console.error is a standard method or standard functionality of Node.js, but we've changed this. We don't have a console in WinCC OA. We have one, but it's something completely different. The console in Node.js is just a text console. We don't have this. So we've redirected all console output methods to write the output into the log. And if you look here, we have here two console infos, JavaScript Manager working, and value of DP name is value. And this is exactly what we've seen here as info messages in our log. These are these two messages. And the last thing I want to cover is here this WinCC OA exit. Normally we would expect that when the main function is finished, it will stop the manager automatically. This doesn't happen in these managers for JavaScript. For technical reason, I will not go into it. So if you want to stop your manager and you're finished with your code, you need to explicitly call this WinCC OA.exit. A lot of managers simply are started with the project and run as long as the project is running. In this case, you won't need this. It will behave the same like any other manager. But if you have some one-shot actions that the manager starts, does something, and then terminates again, then you need this. Otherwise, the manager will still be active, will not do anything, but will be active. So in the next step, we will find an npm package that we can use for geocoding. So to find, locate npm packages, you normally go to the npm website, npmjs.com, but you can Google it, you will find it. And we can now search for packages. We have to enter some keyword like geocoder, and let's see what we get there. Search for it. Okay, and we get 341 packages, which is a lot. So we need to decide which package to take. Normally the first hits are the better ones. But the first hit, which is even an exact match to the name, you see the last change was 7 years ago, and it has a version number of 023, which is not very helpful in this case. I think we need something that is more up to date, and this is probably the next one. It has a reasonable version number. It was updated 5 months ago, and also what you see here is the number of downloads, which is also some kind of indicator. So if we go in there to see it better, we see that we have weekly downloads in the 50,000s, which means this is a module that is actively used, and you can expect to get support there if there are any problems. And we will try to use this one. So to use it, the first thing is you need to install it locally on your machine. The command you're using for that is already here. So we just copy it, open again our terminal, and run this command. Same as with the install before. it will download this package and everything that is needed by it. So you see it added not only this package, but in total of 6 packages. And now we can use this one. And for that, we use our already existing main functions, remove everything we don't need, just keep the exits for now, but we will also remove this zone. So, okay. And we now, the same way that we imported the WinCC OA manager, we need to import this thing. So we can look at the npm page again. We see how it does require this one. We copy it and we will see that there's something not as we expected. Okay, I expected it, to be honest. So you see the require here. This is the old method of using packages in Node.js. If you use TypeScript, you can't use require, you have to use import, as you already see up here. So we just have to change this to import Node geocoder from the same syntax that we have. So, okay. So, the compiler is still not happy. We have 2 error messages. Let's look at the second one first. Could not find a declaration file. So we're using TypeScript. TypeScript wants to check types, and so it needs to know the type declarations. And Node geocoder doesn't have declarations. So this is the reason for the error message. This is a case that happens very often. So there's already a system in place where you can download these missing type declarations for modules that don't provide them by themselves. And the error message even tells you what you need to do. You just execute this command, I copy it here, and it will now download an additional module which contains these missing type definitions. So, and now this error message is gone. And the only error we have, it's here that we have declared a class named Node geocoder, but we're not using it, of course, because we're just starting with that one. Okay, this was the second step. Before we actually use this npm package, we want to test it and try out to understand better how it works. So if we look again at this example in the npm, we see that we need some options, and then we can create a geocoder instance that we can then use to actually do the geocoding. So I copy this and then adapt it to our needs. So just put it here. Okay, so for these options, most of them we don't need. The only option we want to use is the provider. We are not using Google because they need an API key. We will use OpenStreetMap. And we still see an error here. And it tells us this is, again, TypeScript. It wants to check the type, but it doesn't know which type it should be. If we look at the definition of the Node geocoder, we'll see here this definition file we've downloaded, and we see here that somewhere there's a type called options, which contains all these options, also the OpenStreetMap options we need. So we can just tell TypeScript this is of type options. And of course, there's still an error message here because it doesn't know where to get these options from, but it already knows that the definition is in the Node geocoder module, so it can automatically update this, and now we have the options imported as well. It knows the options, the TypeScript compiler is happy with that. And we have here now the only warning, we have a geocoder created, but we're not using it, of course, because we're now trying to test it. So to test it in the main function, we just call a function on the geocoder. And we use this example here. So put it here. Again, be aware we have to wait here because, of course, the geocoder has to go to some server and then get the coordinates for the address. The server answers with the coordinates, and then this geocode method can complete. So we need to await here as well, and we need to see this result. So we just put it on the log file with console info. And if everything works, it should now run. One thing we need to do, of course, we've changed the TypeScript code. We need to compile it to JavaScript. We can use this mpx tsc again. And one important stuff, it's also mentioned in the README, you can add an option called -w, which stands for watch. And this will watch the TypeScript file, and whenever you save a changed version, it will recompile the JavaScript, so you don't forget this step, and it will do it automatically in the background. So it compiled, and it didn't find any errors, so we can try this one out. So let's start it again. Yeah, and we got a result. So that's what the geocoder of OpenStreetMap in this case returns: a latitude, a longitude, formatted address, and a lot of other information we will not use at the moment. So we now understand how this works, and now we can use it and integrate it with WinCC OA in the next step. So now that we know that the geocoder works and delivers results we have expected, we now want to integrate it into WinCC OA. We do the integration in 2 steps. The first part will be getting the address string from OA into our manager and send it to the geocoder. And then the second step will then be, once we receive the result, to write this result back into the database. So before we start with this, a short look at what we have here in the database. So I created a database type called geocoder address, and I have one data point in it called GCA interactive, which has 3 data point elements. It has an address string, which is currently empty. It has a numeric latitude and a numeric longitude field. And of course, there can more than one data point in there. So what we want to do is to do a query connect to get all the data points of this data point type. And then whenever an address is added, a data point is added, or an address is changed, we will get notified and can send the address to the geocoder to get its coordinates. To do so, remove that stuff. We need a DP query connect. So we just check how this API for this is. You see here the auto completion. We have here DP query connect single. And if we type on, we see what we need there. We need a callback. We come to this in a second. I just add it here. We need whether we want to have an initial answer or not. We want to have one. You know this from this function already. And we need some query. So, and for the query, we have a constant and I'll copy it from here. Okay, a typical query, you might see that there are special quotes here. JavaScript and TypeScript have 3 different types of quote. I'm using them here because I can then use the single and double quotes which I need in the query without escaping them. Nothing special there. So now we need this callback, which we haven't defined yet. So if you look here, it has a special type. But in this special case, Visual Studio doesn't provide us the details, so we need to go to the documentation, which we have here. You find it in special functions, WinCC OA JavaScript Manager, and the API section. And the type we've seen here is the DP query connect callback, and we'll see it has 3 parameters, the values that are returned by the connect, the type of the update, whether it's an initial answer or a later update, and possible an error code. So let's add a callback. We have an example here which we can simply copy. Put it here. So remove all the stuff we don't need, like this one. Oh, we can keep it. Okay, so we see a few error messages here. We're using some type definitions from our WinCC OA manager, same as before with the options. We need to add this to the import statement, but this is already provided by Visual Studio Code. So it adds these imports here, and this is okay. We now see this is also not used yet because we called the callback here CB. So let's rename this one. Yeah, doesn't look too bad. And now we, instead of doing this here, we just do an output of the complete values we get from the callback. Console.info values. And let's try this. I've saved, the compiler has already compiled it, and we can start it again. Yeah, what we see here is the typical output of a DB Query Connect. The first is the header line, so we see which data point element we had a query on, and then the other lines data that is returned. So we see this name of our data point, this GCA interactive, and we see the current address value, which is an empty string. So this Query Connect worked. We've removed the exit because this is something that should run as long as required. So we have to step it manually. And now we need this data. Okay, now the values contain all the addresses we want to convert. We can loop over the addresses and call the geocoder for each of them. So as I know, the values returned per Query Connect, the first line is the header. We can ignore this. So our index starts with index 1, which is the second line. And the values also have at the first column the name of the data point, which we don't need yet. This index 1 contains the address. So we get this one. We are converting it to a string so that TypeScript is satisfied and knows the type of this variable. And now we get the location. Call the geocoder geocode method and pass it the address. And we have to be careful, as in the example, we have to wait this because, as I mentioned before, geocode is an asynchronous method. We have to wait until we get the result. Since we have an await here, we have to be sure that an async is in front of the function keyword, but the compiler would warn us if we forgot this one. So the location we want to see in the log file, so we put it out there. So yeah, so you see the result is just empty because we don't have an address here. So we retest this now by setting some value into this address field. Enter Eisenstadt and see what happens. So we see now we got now in our values Eisenstadt, and this is the return from the geocoder. And you see here we have the latitude and longitude again, and with a lot of other data. In the last step, we will now take this location data we've retrieved from the geocoder and put it back into the WinCC OA database. So I've prepared a little something for this. You see here This is the same we had before. We load the locations. And now we need to call dpset, or dpset weight in our case, to set the coordinates to the data point elements where we want to store them. For this, we need the name of the data point elements, which are here, and we need the coordinates. What we were doing here, to give you a little bit more detail, the data point elements of the data point we already received in values. So values at the index E, the first column with index 0 contains the data point name. So we just need to append the name of the element, and the same here for the longitude. These template strings, if you're not familiar with them, they just take whatever is here inside the curly braces, evaluates it, and puts it into the string. So now we get an array with 2 strings with the 2 data point element names, and then we also need to have an array containing the values we want to set, the latitude and the longitude. So locations, the geocoder interface returns not only one location, it returns an array of locations. So very often it's only one. So what we do here is, if we get any result, so if the location's length is greater than 0, we take the first result for this example and put it into the array. And in case we don't get any results, we put 0, 0 in the array to reset whatever values were there before. And what you also can see is we put everything into a try catch block to make sure that if there's an error or something here, that the manager does not terminate, but the error will be written to the log file. We can react on it. Maybe we'll need to change code and terminate the manager anyway, but it doesn't terminate automatically. So we have a little bit the bug output, which I want to remove here. Save it, and let's check if this works now. So we restart the manager because we have recompiled. Okay. And now we try the whole thing out. You've seen already when we started it, it read the data point and already provided coordinates for it. To show that it works, we now add a different address here, and you see the coordinate changes. We can also go somewhere completely different, and it works again. So to just give a short summary, what we do in this callback, so we reconnect single. In the callback, we take the values we get, use the geocoder to convert them to locations, and use a dpset weight to set location into the data point element. One last point, we use dpset weight here, which is something you need, as the name says, you have to await. This makes this code maybe a minimum amount slower, maybe, but you won't see that. But it has the additional advantage that if something happens on server, on the WinCC OA server, when setting this value, like you got a wrong name in there or something like this, we will receive the errors and can then react on that. Okay, this was the hands-on workshop. What we've seen here is how to use a template that is provided by WinCC OA to start your development, how to integrate npm packages, how to interact with the WinCC OA database, how to get data from there with a connect, for example, how to write data there with dpset. And you see it's not too much code. It has some similarity with what you would do in control. And I just wish you a lot of success with your project when you're using JavaScript or TypeScript for the first time. Thank you for your attention, and goodbye.